Hello, my dear sons and daughters. You are warmly welcome to my YouTube channel. Today we are going to discuss fractions lesson in grade 6. I invite you to subscribe my channel and also press on the bell icon. Then you can easily get my videos. First we will discuss what is a fraction, how to identify a fraction. Fraction is a selected part out of a complete unit. Complete unit means we can consider a complete figure here. There are 4 figures given here. In the first circle, I have divided it into 2 equal parts like this. Now I am going to shade one part out of the 2 parts. Now how to represent this fraction? There are 2 total parts. One part is shaded. So the fraction can be written as 1 over 2. This can be read as 1 half. 1 half. In the second figure, second circle, I have divided it into 3 equal parts. Now I am shading one part like this. Now how can be the fraction can be represented here? There are 3 parts. One part is shaded. So the fraction is 1 over 3. That is written as read as 1/3. This can be read as 1/3. In the fourth circle, I have divided it into 4 equal parts. Now I am shading one part. Now there are 4 parts, 4 total parts. One part is shaded. The fraction is 1 over 4. This can be written as, read as 1/4. 1/4. Also this can be read as quarter. Then in the fourth figure, it also divided it into 3 equal parts. Now I am shading 2 parts like this. One part is shaded. Now 2 parts are shaded. Now there are 3 total parts. 2 parts are shaded. So the fraction is 2 over 3. How can we, how are we going to write the fraction here? 2/3. 2/3 is the way we are reading this fraction. 2/3. 2/3. This is the way we are identifying the fraction by using a figure. Representing fractions by diagrams. When doing this, we have to consider the total figure as one complete unit and numerically equal to 1. The first fraction given here is 3 over 8. I have chosen a square to represent this fraction. The square is divided into 8 equal parts as the denominator is 8 here. Now I am going to shade 3 parts in this square like this. 3 parts are shaded. Now the fraction is represented by this diagram. Second fraction 5 over 6. I have chosen a circle and divided it into 6 equal parts like this. Now I am going to shade 5 parts like this. 5 parts are shaded now. Now the fraction 5 over 6 is represented by this figure. 3 over 10. I have taken a rectangle and divided it into 10 equal parts as the denominator is 10 here. Now I am shading 3 parts. 1, 2, 3. This is the way. Then 1 over 7. I have taken a longer rectangle here and divided it into 7 equal parts. Now I am shading one part to represent this fraction. This is the way we are representing fractions by diagrams. What are proper fractions? Numbers which are less than 1 and greater than 0 are considered as proper fractions. If I take some examples, 1 over 2, then 5 over 7, then another one 9 over 13. These are considered as proper fractions. Always these fractions are less than 1 and greater than 0. See, 1 over 2 is less than 1 and greater than 0. All these are the same way. So, then the denominator and numerator of a fraction. How can we identify that? We will consider this given fraction 3 over 7. The number below the line is called the denominator. So, 7 is the denominator here. 7 is the denominator. Then the number above the line is the numerator. Then there is a special point here. In a proper fraction, always the numerator is less than the denominator. If you consider these examples, you can see that. Numerator is 1, denominator is 2. 1 is less than 2. Numerator is this one, denominator is 7. Numerator is less than the denominator. 9 and 13. Numerator is less than the denominator. Numerator is less than the denominator. Unit fractions. Fractions with numerator equal to 1 are known as unit fractions. As example, I can write 1 over 2, then 1 over 3, 1 over 4, 1 over 5. All these are unit fractions. I can write many. So many unit fractions are there. Always the numerator is equal to 1. Denominator can be taken any value here. Then there is a special point here. Any fraction can be written as in terms of its corresponding unit fraction. What does it mean? If I take a fraction like this, 3 over 5. 3 over 5 can be written as with its corresponding unit fraction. The corresponding unit fraction here is 1 over 5. So, 3 over 5 is equal to 3 1 over 5s. 3 over 5 is equal to 3 1 over 5s. Then another one 4 over 7. The corresponding unit fraction here is 1 over 7. So, this can be written as 4 1 over 7s. That is the way we are writing it with its corresponding unit fraction. Now we are going to learn about equivalent fractions. I have chosen two circles with the same size here. And the first circle is divided into two equal parts by me. Then I am going to shade one part in this circle like this. Now the fraction represented here is 1 over 2. Then the second circle is divided into 4 equal parts. In this circle I am going to shade two parts. One part is shaded, then two parts are shaded. Then the fraction represented here is 2 over 4. Now, can you see a relationship between these two circles? Is there a similarity between these two circles? The shaded portion is equal in both instances. So, we can conclude the two fractions are also equal. That means the 1 over 2 is equal to 2 over 4. So, these two fractions are called equivalent fractions. So, the definition is fractions which represent the same value although they have different numerators and different denominators are known as equivalent fractions. These two fractions have different denominators and different numerators, but they are equally valued. So they are known as equivalent fractions. Obtaining equivalent fractions. There are two methods of obtaining equivalent fractions. The first method is multiplying the numerator and denominator by the same number. We'll discuss the first method first. Multiplication method. Multiplication. I'll take the fraction 3 over 5. Then I am going to multiply this fraction by 2. Both numerator and denominator by 2. 3 multiplied by 2. 5 multiplied by 2. 3 into 2 is 6. 5 into 2 is 10. Then this is the fraction that I have obtained. So the fraction 3 over 4 is equivalent to the fraction 6 over 10. Then we will take another example. 7 over 15. I am going to multiply both numerator and denominator of this fraction by 3. 7 into 3, then 15 into 3. 7 into 3 is 21. 15 into 3 is 45. Now we can conclude 7 over 15 is equivalent to 21 over 45. Let's take another example. We will discuss the second method now. The division method. Division method. In division method, we are dividing both numerator and denominator with the same number. I will consider the fraction 10 over 15. We can divide both numerator and denominator by 5. 10 divided by 5. 15 divided by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. So the fraction 10 over 15 is equivalent to the fraction 2 over 3. Then we will take another one. 18 over 20. 18 over 20. I can divide both numerator and denominator by 2. 18 divided by 2. 20 divided by 2. 18 divided by 2 is 9. 20 divided by 2 is 10. So the fraction 18 over 20 is equivalent to the fraction 9 over 10. So the two methods of obtaining equivalent fractions are multiplying the numerator and denominator with the same number, or dividing the numerator and denominator with the same number. But there is a special point here. Every fraction we can take equivalent fractions from the multiplication method. But the division method can't be performed for some fractions. These two fractions can't be used the division method.